All right, welcome to example number 2. Um, now we have a rational derivative, um, and notice that it says you can't tell from a derivative necessarily if you have a vertical asymptote. So it's telling you the original function, which is not given, does have a vertical asymptote at x equals -1. So that's going to come into play when we're looking at critical numbers. So to find the critical number, you set the derivative, again, which is given, equal to 0. The first thing I'm going to do here is factor it, because that will make it easier to solve. And my final simplified version will be this. So according to the definition of critical numbers, you have to figure out where the first derivative is 0. So that's where the top of the fraction equals 0. So those are x equals 0, x equals 3, and x equals -3. Now the derivative is undefined at x equals -1, but that's given to be a vertical asymptote. So it's not a critical number, so there's no mins or maxes that can occur there, so that's not going to be a minimum no matter what happens. So remember, we're looking for a relative minimum. So we're going to set up our chart as normal. We're going to use all the critical numbers, -3, 0, +3. But we also need to include the vertical asymptote because things can change there. So there's a vertical asymptote at -1. So now we have some work to do. But the work's going to be simple because everything here is factored. When we plug into this derivative, we can just use all of our rules of signs. So the first interval, we're going to use -100 because that's in this interval. So when we plug it into the first derivative right here, x squared is positive. So we're going to have up top, we're going to have a positive times a negative times a negative. The bottom of this fraction is always positive because it's squared. So I'm not going to, you don't even have to worry about the bottom anymore because dividing by a positive won't change anything. So here we're going to have a positive times a positive, which is positive. We know we're increasing. Next interval, I'm going to use -2. If you plug -2, you're going to get a positive times a positive times a negative. Don't have to worry about the bottom because it's always positive. So that's going to be negative, which is decreasing. Here I'm going to use -0.5, -1/2. When you plug that in to the derivative, you'll get a positive times a positive times a negative up top, which will be negative. The next interval, I'm going to try 2. You'll get a positive times a positive times a negative, negative. And finally, the last interval, f prime of 90. Doesn't matter. Positive times a positive times a positive. So we go increasing, decreasing, 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 increasing. We're looking for a minimum, so we're looking for where it's going from decreasing to increasing, which is only right here. And that's x equals 3. Done. We have one more example, and that's going to be a trig example, so make sure you take a look at that. See you then.